Okay, hello again, everyone. Welcome to our webinar. We're so glad you could all join us. My name is Farah Alzarini. I'm the marketing assistant at Tom Sawyer Software. And leading today's webinar is Joshua Feingold, who leads the solutions engineering team at Tom Sawyer Software and oversees pre-sale engineering as well as prospect and customer technical support. He is also involved in planning and working on professional service efforts and regularly travels to visit customers and attend events to demonstrate the company's graph visualization and analysis solutions. If you have any questions at any point during the webinar, simply type them into the designated questions box in your GoToWebinar window to notify us. So now I'll hand things over to Josh, who will begin today's presentation.
Thanks, Farah. Hi, everybody. So, as Farah said, I am the Solutions Engineering Manager here at Tom Sawyer Software, and today we're going to talk a little bit about charting and maps in data visualization. So we're just going to start off by talking a little bit about Tom Sawyer Software so that you have some context. So Tom Sawyer Software is the premier provider of software for building high-performance visualization and analysis applications since 1992. We have a number of very nice customers whom you may have heard of. So basically what that means is that way back in 1992, we started out as a company that laid out objects in a graph, so nodes and edges. And then we moved into visualizing those, not just doing the layout, but also doing the rendering, and then doing analysis on those graphs. And now we have more of a broad scope data visualization toolkit that's built on top of this 20-plus-year-old platform that has just kept growing and improving over time. So today the focus is going to be on maps and charts and how they can supplement each other and topology views. And so our agenda for today, we're going to run through a series of 5 examples. Obviously, since we have 5 of them, we're not going to linger too long on any one. But if you do have questions at any point, as Farah said, please feel free to type them into the chat. We'll try to field questions about specific examples as we go through, time allowing. And any general questions that you have, we'll try to address at the end. So we're going to start out talking about an example that shows some of the deadliest earthquakes over the last 100 years, some flight logistics for domestic and international flights, company infrastructure example, a representation of matches that have been played during the past World Cups, again over the past 100 years or so, and an example that shows some corporate governance and who is running these organizations. And then at the end, we'll go over the general questions. All right, so Tom Sawyer Software has a tool called Tom Sawyer Perspectives. What you're looking at now is the Perspectives Designer. We aren't going to be spending a ton of time in here. This is mostly going to be about the examples and not about the tools. But just to give you a brief overview, this is basically a configuration tool that lets you define a schema, pull your data in from some source, define the way that data maps onto things like Google Maps markers, or things like nodes in a tree view, and then very quickly get a nice result. So we're just going to launch a preview here. And this is an HTML5 preview. And this is, as I said, an example that shows some of the deadliest earthquakes over the last 100 years. So just to kind of walk you through who might be interested in this and why this looks the way it does. Perhaps you're a regulator, you're trying to discover which building codes are the most and least effective, so you're interested in charting, by geographic area and by year. How do large earthquakes translate into fatalities, or conversely, how do building codes prevent fatalities, which is obviously something you're very interested in. Maybe you're a researcher, you're looking for trends of population growth versus technology improvements. Obviously, in India, if you have an earthquake today, there are going to be many, many more people who are potentially affected by an earthquake than 100 years ago. But at the same time, the technology and the building codes have improved, and you may see, trends in one way or another. You might even be an executive who's looking to expand overseas, and you want to know, where are my earthquake risks? What is it that I'm interested in? Maybe it's only the last 30 years. Maybe I'm interested in not the scale of the earthquakes, but how deadly they are. So we're just going to talk a little bit about how we can visualize all of these pieces of data together and just kind of check it out. So let's go ahead and focus in here. So yeah, so we have a couple different markers on the map here. You can see that we have flags. Flags represent individual earthquake events. And we have these dots, right? So these little balls here that represent clusters of earthquakes that all occurred close enough to each other that putting two flags next to each other would look confusing, essentially. We're doing a little bit of processing on the server side to determine where to render a ball versus where to render a flag, but nothing fancy. And we can select our earthquakes anywhere we want to go. So this is all coordinated together. These are some magnitude 7 earthquakes between 1990 and 2015. Right. So maybe we're interested. So we've got this, and it's nice that we can see it in the chart. But let's say we want to supplement this just a little bit. Let's go ahead and close this out, and maybe we'll go back to Designer. Want to see the details of the earthquakes that we're clicking on, so we'll just go ahead and add an inspector view. It'll be for earthquakes. And let's just grab the date. We're interested in the death count. We're interested in the magnitude. And let's also grab the location, because that's pretty interesting information. And while we're at it, the balls versus the flags, that wasn't terribly distinctive. So let's jump into the definition. Let's change the marker properties. So instead of a ball here, we'll have this as a warning sign, because we're a bit worried about that. Let's save those changes. Launch a new preview. All right, so now I've changed my layout to be a little bit more interesting to the type of information that I want to see. We've got this inspector view down here. So if we select this earthquake, we can see that this happened on December 13th, 1982. There were 2,800 deaths, and it was located in Yemen, and it was magnitude 6. Right. So now I'm really starting to build out from geographic information and chart views. I'm starting to build out a broader understanding using multiple views on my data. So let's dig a little deeper into each of these use cases that I talked about at the beginning. So let's say I'm the regulator now. What I'm mostly interested in is probably a specific geographical area. So let's fit in, let's maybe center in on India, right? India in the Middle East, and I can see, now I can zoom in, and I can see, well, okay, so this was a magnitude 8 that resulted in 4,000 deaths. This was a magnitude 7. This was a magnitude 7.6, right? And now I can compare based on these dates and these geographical areas. Now that I have my region of focus, I can really come in and look at neighboring countries, right? Azerbaijan, Armenia, Turkey, Iran, and I can see, in one country in a specific year, an earthquake occurred. This was the overall impact of that earthquake in terms of loss of human life. You know, this was the size of the city where it hit. This is the set of building codes that affected it, right? So I could use all of these views coordinating together to really see what I'm interested in seeing. Maybe I am looking at this growth research, so I only want to separate out the most distant, right? So I want to get the biggest difference I can, so I'm just going to take out these middle years. And now I can see down in my chart view, right? I can see how the earthquake at a given time resolves into resolves relative to the magnitude, right? So here, you know, we can see that this is, you know, a 1929 earthquake, and this is a 1990 earthquake, right? So these resolve together, and I can look at where they happened. I can try to figure out, based on my parameters of population and regulation, you know, over this large span of population growth, right? So here are 3 in Singapore, and we can figure out exactly what it is that we want to see, right? And now we can even look at the most recent and the least recent only in our chart view. So perhaps we're interested in seeing the total distribution on the map because we want that graphical reference, but we want to filter our chart view down to just those 2, right? So we can even do that independently. So it's all about using your different views on your data. You know, maybe we can see that kind of most of the action here is happening between 6 and 8, so we can even do a little filter there. Go to 6, bring it down to 8. Now we can get much more dense data based on our area of interest, and we can, you know, simplify our maps that we're looking at to get rid of the biggest earthquakes, which are really outliers, and smallest earthquakes, which don't have much impact. We can also put this side by side with some statistic about the overall number of earthquakes, and we can say, okay, well, I'm very interested in these really small earthquakes. But now we can see that, well, the small earthquakes are very dominant in terms of count, even though they don't have a big impact on you know, property damage or human life. So you know, if we're just looking at the raw number of earthquakes in an area, that may be deceptive, but it may also be something we need to take into account, right? So we can see that there's this logarithmic decrease from 4.0 to 4.9, and then 5.0 to 5.9, and then 6.0 to 6.9, and then through the 7s and down into the 8s, right? So we have this logarithmic decrease in number of occurrences, however they are significantly more catastrophic. Right? So that's kind of what we can see in this earthquake example. So let's move on to another one. Do you have any questions that are specific to this example? It doesn't look like we have any specific questions here. So I'm going to bring up our next one, which is about international flights. So again, we have a nice example here that we're just going to launch in our previewer. And the data that we're seeing here is a collection of routes on Hawaiian Airlines. So we can see that right now we are only showing our domestic flights, but we also have international flight data. Now we've filled them in. We can see this sort of global route map for Hawaii Airlines. We can see which airport we're clicking on. Right? We've linked all this together. Or we can go ahead and select an airport in Japan that we want to see. Right? So why would this be interesting? Um, Obviously, this is kind of like a cool graphic if you're somebody who's interested in airline routes. But more importantly, maybe you're an airline executive. You're trying to determine what your year-over-year growth is along specific routes in and out of Hawaii relative to the growth on those airports, right? So you can see that, you know, this is Honda Airport in Tokyo, and a passenger growth rate from 2011 to 2012 of 5 million passengers per year. So that's about 7%. And so we can compare the growth rate of the airport to the growth rate of flights to Hawaii and find out if we are doing a good job capturing that market. Maybe there's a lot of growth there, maybe there's very little. Honolulu, obviously this is our central airport, and if the central hub airport here is not is tracking well above our growth as an airline, there might be something that we want to look into in that department. Maybe I'm a hotel marketing director and I want to use, and so now, the year-over-year growth isn't that interesting, right? So I'm just going to get rid of these 2011 figures. I'm just going to look at what are the biggest airports here where I could, buy some billboard space, or put something over the moving sidewalk so that I could remind people, hey, Hawaii is a nice place to come visit. And the answer is, is somewhere in this data where we can compare the size of these airports, the total traffic, with the cost to purchase a billboard in that airport. Maybe I'm an executive from a rival airline or just from a non-overlapping airline. You can see that Hawaii Airlines, we have this very good geographical view of what their coverage is, right? Nothing to Mexico, nothing to South America, nothing into China or India. Nothing into Europe or Africa, but there are practical limitations there with the range of airplanes. But maybe it's the case that I want to either think about adding some direct flights from Mexico, adding a direct flight from Peru. Maybe I'm an Indian airline and I want to figure out where it is if I want to start promoting, that we can get you great routes to Hawaii. What are the airlines in East Asia that we need to link into in order to see what it is that we need to learn, right? So again, this is, you have a different perspective and a different interest based on what it is that you want to learn and what your objectives are with a given map. But it's still the case that you want to be able to take this core piece of information, right, and you want to be able to extract out the most important data for you. So let's move on to next example. Do you have any
Hey Josh, I
questions
think
about that?
there's a question. Yeah.
We do have a question now. Okay. Okay, so do you have any examples that are on a smaller scale, such as within a municipality, aka how does TS handle small scale graphing? So for maps, let me bring that back up. So for maps, we use the Google Maps API for the time being. And you can see kind of as we get closer that because of the way Google Maps works, we have, the resolution that is kind of built in, and you can place a large number of pins. You can use heat maps. You can use clustering, as we did in the earthquake example, right? It's not particularly relevant in the airline example, but you can use basically any approach that you want that links together the data from your source to a representation on the front end, right? So as we zoomed in, if this were a cluster of events, this could spread out and be a whole bunch of markers that are spread around Honolulu. All right. So with that, let me jump on to our next example. And that's going to be the company infrastructure. All right, let's go ahead and launch a nice web preview of that. So here we have a fictional company. It's got a number of departments. Let's see what they are. So we've got administration, documentation, finance, graphics, marketing, operations, products, quality assurance, sales, solutions, systems. All right, so we have all of these departments that make up our company, and we have a company hierarchy and figuring out who answers to who. Obviously, a very important task if you're, for example, an executive or a manager in human resources. So we're just kind of going to look at how we can use use both this topology view along with a geographic view to get a better understanding of the way our company is actually put together, right? So here we have a map of where everyone who works for the company lives. So let's jump in and find out where our administrators live, or not live, but work. Okay, so when Google Maps catches up here, it'll tile in. This is in San Jose. There we go. We got a little too. Oh no, it zoomed down on a different location. Okay, so yeah, so I was thinking of a different example. Okay, so here you can see that this is a company that has an office here in China. Maybe we can jump to the documentation group right here. So here we have Beatrice. Beatrice is a product development engineer. She lives in Warsaw, Poland. You can see Theodore. He also lives in Warsaw. Here we have a manager in Tel Aviv for our sales department. And if we jump to the company hierarchy, we can see that this is linked together. So basically, we're interested in learning about the dependencies of our company, both in terms of a logical view and a geographic view. Here we're seeing a very individual, very human-centric view of it. But we can also add another degree of abstraction. We can group these by department. Now we see the departments overlapping on one another. Here we go. We've applied a layout. Now we can see the dependencies that exist not only from person to person, but also from department to department, right? So we can see that this node up here is the administration group. Here's the finance group, right? Let's find out where the graphics are. Oh, so here are the graphics. They depend on these documentation nodes up here. Right, here we have the big products group because everybody likes products. Right? Quality assurance flows out of the products. And here, we just see our full hierarchy of what it is that exists in the company. And, we can ungroup these by department. We're not interested in that anymore necessarily. Just do a nice zoom to fit. Let's find out where our chief financial officer lives. So we're going to select him here. And go to the company map. Here he is. Okay. Okay, so you can use this not only to show what the company looks like in terms of your functional management, but often there is a parallel administrative management for handling things like taking leave, administrating the office. So here, let's get rid of our functional management. Now we can see that we have a very different hierarchy. But it's very easy to get this view as well. You can see that there is a lot more interdepartmental connectivity here because we want people in similar time zones. And if we jump to the company map, you can see that we've got different edges. So you can see that all of these offices are connected fairly differently if we show the administrative management versus showing the functional management. And again, we can jump around and see where people are located. And we can even see both sets of managers together, although that can get a little messy. So having a nice automated layout function is pretty important, right? And we can even group by department, so we can see what the dependencies all are here in this very complicated view. So can use this to learn things about your company that might otherwise be difficult to see. Where are your bottlenecks? Who's managing whom? What people are being overloaded in a way that's being hidden if you are only viewing some subset of the data, or if you're only viewing the company hierarchy. What is it that's in the company map that might be important and that might be telling? So these are always important things to keep in mind. Right, and here we have these management link edges, right? So you can see that Judy M. Schnell is managed by Irma R. Watson within the sales department. Here's an administrative edge. And here we can see that Gary Gardner is managed by Florence Johnson from the Rio de Janeiro office to the Chinese office, right? And this type of technology obviously is very useful if you want to visualize not just what does my company look like right now, but what could my company look like if I added an office in India or in South Africa, or if I wanted to add another person in Taiwan, right? So this allows you to kind of get this simultaneous view of all of your management structure, just kind of all at once. Keeping things nice, keeping it comprehensible by a human, and that's really the point of all of this.
Josh, there was a follow-up question to ask if we can do things even on a smaller scale, such as individual building maps, college campuses, and hospitals.
Yeah. So the answer is yes. We have plans that allow us to basically impose very fine detail on specific pieces of geography, from very complex down to very simple. Unfortunately, right now we have paperwork that is being filed for patents for that, so I really can't go into a huge amount of detail, but the answer is yes. So right now you can use Google Maps down to a very fine level of detail just by zooming in, but there are things in the very near future that will make it even better.
Okay, thanks. There's also one more question from someone else. Is there any way to fold in time zone information into these views?
Yeah, so these are fully attributed views. So let me just launch that again. So right now, the only thing that we're using to color these nodes in our logical view, as well as in our company map, are the department that a particular individual works in, right? So that's the only indicator that we're using at the moment. However, this is a very open-ended hierarchy. You could overlay in one or both of these view types the ability to add an additional indicator which could show seniority, right? I mean, there's some reflection of that in the hierarchy, but not necessarily all of it that you're looking for. You could show time zones, which you could derive or directly read from a data structure. You can basically add anything that you want to add to these visualizations. So the answer is fundamentally yes. This is a very simple example because we don't want to go into exhaustive detail and show people stuff that is perhaps too specific. But yes, any information that you can explicitly store or infer from information that is stored, you can add into either your topological view of the company hierarchy or your map view of the geographic locations of the workers in the company.
Great, thanks.
All right. So yeah. So yeah, I guess I can just zoom in here, and we can do a little of the really showing off the level of detail here. What's going on, right? So this isn't on a campus, but this is you can see that there are these edges that you can get very fine level of detail, right? So here's our employee in Paris, and you can see the runways at the airport, right? All these individual bodies of water around here. So there is quite a we can even go to the satellite view, right? So we can see this in whatever detail we want, right? So this is all just inherent capabilities of Google Maps that we are exposing and taking advantage of to link into our larger framework, which shows data in all of these different styles of view. All right, well, if that's it for that one, we can move on to our next example. So the next one is a little bit of fun. So depending on which part of the world you're from, you may have interest in soccer or football. But we have a nice little example that shows off what you can do with some of our views together. So here is a view of some World Cup matches. So here we're showing group stage matches from 2010 and 2014 World Cups. We have a nice little representation of who our high-scoring teams are, right? You can see that the Netherlands scored 15 goals in the matches they won, Argentina 13, Colombia 9. Right, and this is during the group stage. But maybe we're not interested in the group stage. Well, we'd rather see, the matches that really count, the quarterfinals through the final. And you can see, Germany in this stage is really very big score, and the Netherlands as well. So you can pack in a lot of information in not a lot of space with this type of view, right? And you can view different types of information in different types of views, right? So if I zoom in here, and I see this this German node, I can see all of the matches that were played. I can see in aggregate that Germany scored a lot of goals, scored a lot, 22, and that the Netherlands scored 8. The Brazil scored 7. So we can see that Germany scored a lot of goals, but we can also see these specific results in a very granular fashion, right? So here's a 4-0 victory for Germany. Here's a 1-0 victory. This yellow edge indicates that it's a final. We've got a 1-1 victory with an extra point. We have a 2-0 victory for Brazil up here, and a 7-1 victory in 2014. You know, it seems like a pretty good way to get back at them for this 2002 loss, right? So we can see that there's a lot of detail that you can pack in when you use a very granular view like a topology view that you can really annotate very heavily, and then you can use it to supplement the sort of metadata view or aggregated view that you get from viewing in a less in a chart, right? So you can't in practical terms show everything that you want to in a chart, but it's nice for aggregating data that maybe not as elegant to aggregate in a drawing view. Right. So let's kind of play around with this a little bit. So we can see, you know, we can do a little compare and contrast. Right. So maybe if we do the group stage, I want to get rid of some of these matches. So we only want to show the group stage and the finals, right? So we're interested in the sort of general importance matches and the most important matches, and maybe we're interested in everything for the last 30 years. So we'll go back to 86. And let's not even look at the group stage. Let's just look at the final, right? So here we can see, you know, this is a pretty interesting graphic right here, right? So you can see that Brazil played in 3 finals in the last 30 years. You can see that they lost once to France. They won twice. Argentina also played in 3 finals, although they only managed to win one of them. And you know, one of them is against Germany, and the 1991 was against the Federated Republic of Germany. There's a little name change there. Should not come as a terrible surprise. So you can also see, you know, maybe we want a little more historical information. So we'll get rid of these new ones. All right, and so you know, if I'm a sports fan, this is pretty interesting. But you know, even if I'm a sports broadcaster, you know, this is pretty cool stuff. I can get, you know, 1930 to 1945. What did the group stages look like? And you can see, you know, we can zoom in. We can see all these edges coming out from Brazil. We can see that they've been pretty successful here, right? So this was a tie, so nobody won. But otherwise, we have these little flags that represent victories for Brazil in these 1930 to 1954 World Cups. You can see that, you know, when you're talking about the group stage, you know, maybe Uruguay is pretty interesting. So let's select Uruguay. Oh, that's pretty cool. Maybe Hungary. So Hungary only had the 2 matches, but they were pretty decisive. Right, so this is a 9-0 and an 8-3 in the 2 1944 or 1954 World Cups. So you can see that you can use multiple filters, right? Multiple types of filters, multiple types of views to really get exactly the data that you want without being limited by sort of narrow representation that you might get if you could only view this pie chart, right? I mean, you'd be missing out on a ton of detail if you could only find out about these, and if you tried to view just the matches, you know, you'd be missing out on this aggregate information that it'd be difficult to get the big picture view, right? So it's very much about taking your data and using not just one view, but multiple views working together so that you can really get the detailed, fine information in one view and the more aggregated, broad information in other views, or using filters or doing whatever it is that you need to do to see, you know, what is it that really counts in my data. See if you have any questions about this. Okay, no. Move on. Yeah, it looks like we are on our last example, and that's about all we have time for. So we're going to look at the corporate governance example. And if you have been a follower or worked with us in the past, you've seen older iterations of this example, but because we have this new capability, we can show the same type of value here that you can get from looking at these aggregated companies that you can otherwise have a tough time viewing, right? So we might be interested in looking at which company has the most total owners, right? So here's this Mantech International Corporation, right? So those big corporations surrounded by a lot of folks. And we can again use the power of our filters to add or subtract information, right? We can get rid of these connections between everything other than directors, and maybe we'll do another layout. All right, so now all of these people are either officers or have other connections, but we've narrowed down our drawing to within the main topology to only show the directors. And maybe within the directors, we're only interested in those who have connections to at least 2 companies. So now you can see that we've really narrowed down the data set. And now that we've got this data set that we're interested in, maybe we'll go over to a social network view. And we'll see not only who who is connected to each company, but using an inference that if people are connected to the same company, they are also connected to each other. We can create a social network, right? And we can run through some of our cool centrality algorithms. All right, so here's a betweenness centrality. This shows which individuals within the network lie on the shortest paths lie on the most shortest paths between other pairs of individuals on the network. So here's this Marshall Geller and Jerome Feldman. Right? Are these kind of 2 fancy movers and shakers here? If we go back to the company view, we can also see, maybe we're not just interested in viewing it as a company, but we're interested in viewing the clusters that exist here. And fascinatingly enough, we can see that Marshall Geller, who is a very high degree of betweenness centrality within the social network, is a link in this company network that connects 2 clusters. Right, and we can also find out some things about the companies that he is associated with. So let's jump in, and we can see that he is associated with Spice Holdings. Sorry, I'm definitely saying that wrong, but I can't say it correctly. So you can see all the different companies that he's associated with. The statistics for this view. So we've got 40 companies. We have various people. So we can also look at some of these other people of interest, right? So here's Scott Greenberg. So we can see these very strong trends that people who have highly central positions, when we view them in these circular clusters, right? So this is a logical cluster detection, are either located within the center of the main cluster, which means that they have a lot of connections within the cluster, or they are located on the edges of outlying clusters, right? So Marshall Geller is the bridge between this cluster and the central cluster. And we can compare the centralities of people with the attributes of companies for which they work. And this is kind of interesting as an intellectual exercise, but it's mostly interesting if you are, for example, an SEC regulator, or you are an owner of a business and you are trying to be purchased by another business. business, right? You're trying to get bought out. These highly central people have connections to people, and not only do they have connections to people, they have connections to people who in turn have connections, right? So these are the people that you want to look for if you're trying to raise funds for a specific organization, or maybe you're associated with a nonprofit. Maybe you're just looking for industry partners for some new venture. So these are all ways that you can use the linkage between seeing, so here are these companies that have a lot. I can get a lot of feet in the door there, right? There are a lot of opportunities. Here's a company where I have to be very selective. But maybe, it turns out that this company that only has a very few people associated with it also is connected to this Ori Lee Taos, who happens to also be very central in the network. So I can get in with this very small, difficult to contact company at the same time that I can form connections with lots of different other companies that he happens to be associated with. Right. We can also change the degree of the filter and see how that changes our impact here, right? So. Yeah, you can see that there are many different ways that you can view this data to really get at what is important to you, right? And it's that coordination between views that really lends you power that you can't get from any individual view by itself. And that's why you want to think about not just what is the single point of data that you want to look at. Do I want to make a chart? Do I want to make a graph? Do I want to make a map? And the answer is no, you don't want to do any one of those things. Like in many cases, it is the coordination of all of these things together that really brings you the power and value and insight that you're looking for when you want to visualize your data. All right. So that brings me to the end of this set of examples. So if people have questions that are either related to specific examples that they didn't ask at the time, or you want to ask examples that are more general about different views or the way you can think about certain problems in terms of aggregating in graphs, viewing specific topology data and drawings, and viewing geographic data in a map, and having all of those things work in conjunction. This would be a fine time to ask.
There's a new question, Josh. It says, how does this compare with tools like Gephi, Graphviz, etc.?
Okay, so I'm not familiar with Gephi, but in general, so there are a lot of tools out there that let you draw nodes and edges. There are a smaller number of tools that let you draw some nodes and edges, and also maybe draw a chart or connect it to a map. And there are no tools out there that have those attributes and have been working on a centralized conception of data and extremely high quality layout for 20 years. So if you're talking about how this technology compares, the answer is that it's in maturity, quality in terms of both the layout and the visualization, and in terms of getting effects, like this coordination between your data, right? So this is not actually a social network view and a company view and a total owners chart, right? These are not independent quantities, right? These are actually a single conception of data that we're using to create the sort of multifaceted view, but it all comes back to the centralized data source, right? So toolkits exist to do some of the components of this, but in terms of creating a high quality, holistic representation of your data that all inherently connects to the other representations, you know, Perspectives is kind of it in that space.
He also has a follow-up question. How much of network science theory does one need to know to use the tool effectively?
So if you are a developer, right? So if you're a developer, you should have a clear understanding of what it is that you want to see. And that may be derived from knowledge that you get from a background in network science where you have specific algorithms that you want to run, or you have, you know, you've got some very specific ontology that you want to represent. On the other hand, you may just be, you know, a guy who knows that I have these people, these are the types of connections that they have, and I want to draw that. And really, Perspectives caters to both ends of that spectrum. We didn't spend a lot of time in Designer, but the reality is that this is a very simple tool to use, right? So, for example, for every person that I have in my model, I'm going to add a node to the drawing. And for every company that I have in the model, I'm going to add a node to the drawing. And for every relationship that I have, I'm going to add an edge. And for every company to person relationship, I'm going to add an edge. And then I'm going to apply a template based on the general type. So there isn't a lot of knowledge that's required. If you have a huge depth of knowledge, you can definitely utilize all of it. But this is a very simple and user-friendly kind of development environment. And once the development has been done, the end user, right? So the person who is looking for the investors, he doesn't need to know anything. All he needs to know is, you know, just like you don't need to know anything about, you know, geolocation to use a Google map to, you know, find the nearest Starbucks, right? You know, this is the same thing. Once the design is done, the end user can be extremely naive and just knows what he wants to accomplish, and that someone has set it up to accomplish it for him. You know, the end user never has to go in and configure anything. He's just using a web application that, to him, is just like any other web application.
And then a follow-up to that, can it represent dynamic data like Twitter streams?
Yeah, so it absolutely can. So the data representation in Tom Sawyer is basically agnostic to what the backend looks like. So you can connect it to a Neo4j data source. You can connect it to a SQL data source. You can connect it to a stream of data coming in from a Twitter feed. Or, you know, you can even connect it to an Excel data sheet, right? You know, for this example, you know, this is just connected to an Excel data file. So, you know, it really runs the gamut. And it has an update commit architecture. So whenever you want to get more data from whatever your data source is, you tell it to update. It pulls in whatever changes have occurred in the data source. If you're working interactively and you want to be able to push data back, you can hit commit, pushes back to the data source. And you set up basically whatever rules. So you could have your person who's viewing the Twitter data stream, you know, either it automatically updates every 5 minutes, or it automatically updates every time there's a new tweet with a specific hashtag, or the person can work and learn what they need to learn, and then when they're ready to bring in the next batch of tweets, they can bring in the next batch of tweets manually by manually initiating an integrator update. So there is a very wide breadth of ways that you can have your end users interact with the data, and you basically, as an application developer, you know, just figure out what it is that you want that behavior to be, and then you can make that behavior happen. All right, so did that get all the questions?
Yep, I think so.
All right, well, it looks like we've got about 2 minutes left on our scheduled webinar, so I think we came pretty close. If anyone has questions, do you have the appropriate email for them, Sylvia?
Yeah, we will send out a follow-up email, so a thank you email with the recording, and it will come from marketing@tomsawyer.com or my direct email. So you can either email me directly or email to marketing@tomsawyer.com.
All right. So yeah, that's all I've got. Unless there are any other questions, I will throw it back.
Great. And if anyone has questions, I guess you can just let us know. So thanks so much, Josh, and thanks for everybody for attending.